Today's topic is phase change diagrams. Okay, phase diagram is a graph. You can see it is a graph that shows state of a substance, say for example solid, liquid, gas at a different temperature and pressures. Okay, this graph contains, you can see in x-axis it is temperature, y-axis it is pressure, and there are lines. Each line is representing phase changes. Say for example, I'm drawing this red line. It is showing a change from sublimation and deposition. That means sublimation and deposition means a conversion of a solid into gas, directly into gas without passing through a liquid state. Okay, sublimation is solid to gas and deposition is the opposite. That is, gas is converted into solid. Okay, next line. Each line represents a phase change. This purple line shows a change from what to what? A liquid to gas and backwards, gas to liquid. So purple shows a change from liquid state to gaseous state, which is called vaporization, and the opposite, that is called condensation. So then the third line, that is this one, that represents the changes called melting and freezing. So melting and freezing means solid converting into liquid and backwards. The third terminology you already learned, freezing, and we also learned another scientific term called fusion, because enthalpy of fusion we already learned, and the opposite is called melting. Okay, so sublimation and deposition are solid and liquids are converting each other. Sublimation and deposition is the opposite of that one. And liquid to gas, we'll call it is vaporization. Then the opposite is called condensation. I'll write on the bottom, don't have space. Okay, so each line represents the phase changes and each area, okay, represent a state. That means, the highlight, this area these areas are called solid, and this area is representing gas, and this one is liquid. I should go out and write that. So this is solid, and this one gas, and this one liquid. So now you understand how the phase changes are happening, right? So here we are going from solid to gas. Okay, here we are going from solid to liquid, and here we are going from liquid to gas. So these changes you can do by changing two variables, either by changing temperature or by changing pressure or by doing both, right? So we are going to see how you can convert a solid into gas or a solid into liquid or liquid into gas, or the opposite by changing pressure and temperature. So first you have to understand the graph. There is more coming about the labeling and definition. This point here, this state, okay, I'm going to use a different color. So this point, there you can see at that particular point, there is a coexistence of solid, liquid and gas. All of them are touching here. Okay, and that is called triple. The word itself says there are three, right? So triple point is a point where three states exist together. Okay, then another definition, this one. There is a maximum temperature and pressure. Beyond that point, we cannot change the phase changes between solid and liquid. Okay, so even though if that is a unique temperature and unique pressure for every substance, it depends on intermolecular forces. We are not discussing that here because that is, you don't need that for advanced chemistry. So that is called critical point. Okay, critical point is a maximum temperature and pressure. Beyond that points, the phase changes between solid and liquids are not, it will not happen phase change. Okay, now a phase diagram, again definition we already discussed. It's a graph of pressure wise temperature of a particular substance. Each substance will have a different type of, everyone think has three lines, but it will have different shape, a little bit of different shape. It's shown in what state of matter exists under any combination of pressure and temperature. It can also use to predict the phase changes under known condition. Like if we know temperature and pressure of a particular substance, we can predict what is it, a liquid or solid or gas. Okay, then equilibrium. Okay, equilibrium means something they are equal to each other. We already learned thermal equilibrium, right? Thermal equilibrium in our zeroth law of thermodynamics. That means there are three substances. When they are in same temperature, that is called thermal equilibrium. So here in phase diagram, the equilibrium means equilibrium between two substances or equilibrium between three substances, like that. So definition of equilibrium is a general word, but when you apply to each situation in science, the definition may change. Okay, so here we can say equilibrium is a condition where more than one phases exist at the same time. Okay, go ahead and write a condition where more than one phases exist together. Exist at the same time. Okay, so one very good example, you already know that, like if you have a cup of ice and if you are adding little bit of water, like we did an experiment for heating car, there is like maybe 50% of ice and 50% of water at 0 degrees Celsius if you add both of them together. Okay, so that is a thermal equilibrium between what and what? Ice and water. So that happens at 0 degrees Celsius. There will be equal amount. 0 degrees Celsius is a melting point or freezing point, right? There will be equal amount of ice and water. Okay. So that is called equilibrium. Then triple point, the temperature and pressure at which three phases exist in equilibrium. You already explained that, okay? So it is a point in a phase diagram. That means it is a value of pressure and temperature at which exact temperature and pressure at which all three phases, like what are the three phases? Solid, liquid and gas exist together. They are all in equilibrium. Then critical point, at a particular point in a graph, beyond that point, it is very difficult to do the phase changes between liquid and gas. Okay. We can write it is the value of the temperature and pressure beyond this point, phase change is not possible between liquid and gas. Or we can say, liquid and gas are indistinguishable there. We can't say based on the property whether it is a liquid or whether it is a gas. It will act like a supercritical fluid. It will act like a supercritical fluid. So it will behave like a gas and behave like liquid. It will have both the properties like gas and solid. Okay. Then boiling point. Okay, boiling point is the temperature at which we can say like vapor pressure becomes equal to atmospheric pressure. That is the exact definition. But here in terms of phase diagram, we can say it is the temperature at 1 atm pressure. Okay, then melting point, temperature at which substance holds. Okay. So there is a equilibrium between liquid and gas at the boiling point. Okay. Then melting point. So temperature at which temperature of a solid which changes at 1 atm pressure. Okay, this is based on vapor pressure. We are saying here temperature of a liquid at 1 atm pressure. Okay, that is the temperature needed. So here there is an equilibrium between what and what? Solid and liquid. Okay, so those are the basic understanding, like explanation for a phase diagram. Now let's see how to do some of the questions based on the phase change diagrams. Okay, so here this is the phase change diagram for water. Actually the diagram is a little bit slanted this way, like this. It's like a negative slope this way. Okay, okay. What state of matter is water in at 10 atm pressure and 300 Kelvin? Okay, so 10 atm, so this is 1 atm, then the scale is very big, so you have to assume like 10 atm is somewhere here, right? 10 atm here, and 300 Kelvin pressure. So this is 373, this is 273. So it will be, there somewhere here, right? So I'm going to going up that 300 Kelvin. And when I reach here at 10 atm, so suppose this is 10 atm, scale is very difficult, you know that, because 300. Okay, so what is the state there? What is the state you are seeing there? So this area, remember the labeling, this area is what? Liquid. So I'm gonna write the state of matter at this condition is what? Liquid. Identify the normal boiling point of water. Then we said normal boiling point is the temperature at 1 atm pressure, right? So of water. So if you extend the line, this is 1 atm, maybe I'll use a different color. This is 1 atm, then we go here, it is reaching here, and what is the temperature there? 373 Kelvin. That is the normal boiling point of water, which is 100 degrees Celsius, as you all know. Then if pressure is 200 atm, that's what I said, if you are boiling water in a mountain, or if you are boiling water in a valley, that boiling point will be different. We learned that in gas laws. Okay, so here it says 200 atm pressure. Okay, let's see. 200, so this is 370, maybe 200 somewhere here, right? So 200 atm, you are extending the line. This will reach here. Okay, right? So then what will be the temperature there, right? We can say approximate maybe 580, 500 or something like that. You can approximate that 500, approximate 500 Kelvin. So boiling point is increased because pressure is increased. Okay, now can I sublimate at 0.5 atm? Okay, let's see. Sublimation is a process of changing from what to what? A gas into what? Into solid directly. So this is a region where sublimation is happening. Okay, now let's read the question. It says 0.5 atm, can you sublimate? I would say no, because 0.5 atm is here somewhere. 0.5 atm, if you change So that will not happen. It is between what and what, solid and liquid. So it will not be possible to convert that into gas into solid, because we need to have this area, right? We need to have this area which is below 0.06 atm. So go ahead and write that. No, because P must be lower than what? 0.006 atm. Okay, next question. If I have a 10 ml of water, 0.8 atm and 3 temperature, describe the phase changes that occur. So we have to go 0.8 atm. Okay, so that is somewhere here, right? 0.8 atm and 325 Kelvin, that is here. 325 and 0.8, so that will be still what? Liquid. So no phase changes, so that will be, it will be a liquid itself. Liquid, that means it is water itself, right? So no phase change. You can increase the temperature to happen, like if you go here, that will convert it into what? Gas. But now the temperature is only 323. We need to go above 373 Kelvin to make that happen. I raise the pressure to 100 atm while keeping the temperature constant. Okay, temperature is again 325 and pressure is what? 100 atm. 100 atm will be maybe somewhere here, right? So if you go to 100 atm keeping the temperature constant like this, 200, I raise the temperature 100, so that will be here, right? Still that is a liquid state, so we can say no, nothing will happen, no phase change, it will be still water, right? Because it will be still water. Now I hold the pressure constant and the temperature is 400 Kelvin. Okay, so we are keeping the pressure constant and the temperature is now 400 Kelvin, which is here. So the temperature pressure was 0.8 atm. So that means we are here, temperature is 400 Kelvin, so I would say that will be here. Okay, we can say there will be a phase change happen. Approximately the liquid will convert it into what? Gas. That is called vaporization will happen. If I keep 400 K constant and increase the pressure from 0.8 to 120 atm. Wow. So we are here, pressure is 400, sorry, temperature is 400. Pressure is increasing to like something like 120 atm. So that means what will happen? We are condensing, right? So we are somewhere here, it will go back into what? Gaseous state. So applying the pressure, we know that gas molecules like coming closer, so that gas will convert into liquid, and that is called what? Condensation. Okay, so you can expect this type of questions on your test also. Okay, now let's practice this one. If you guys need help, I can do that. I'll record that also. But first, try to do that by yourself before you checking the answers in the video. Okay, I have a piece of dry ice. Dry ice, you know, the dry ice that is called solid carbon dioxide at a 10 bar pressure. Its unit is different, okay? 10 bar pressure and minus 60 degrees Celsius. Changing one of these, but only one at a time, what specially I can do to convert into gas? Okay, let's see. So I have a dry ice at 10 bar pressure. So 10 bar is somewhere here, and the temperature is 60, which is here. That means I'm somewhere here. This dry ice is somewhere here. Okay, I want to convert that into gas. Okay, that means I have to bring this one in this region. Okay, that is the highlight. Okay, that is the region we have to bring. Okay, so what we can do, okay, if keeping 60 degrees Celsius same, you can lower the pressure. Okay, if we lower the pressure, we can reach the green area, which is the gas area. So I'm gonna write keeping pressure temperature constant at minus 60 degrees Celsius, decrease pressure below what? Below, I would say, like maybe here, somewhere here, right? Here. So that will be 2 bar pressure, or maybe I think that will be like lower the pressure. Okay. So you don't need to write the value because scales are off. So we can say decrease the pressure below 5.18 or maybe 4.18. Let's go like that. Okay. Then, or you can do the second thing. We will also do keep the pressure constant, and you can do what? You can increase the temperature, right? Then we can reach here. Okay, second one, at 10 bar pressure, increase what? Increase temperature. That means you will move towards the right. Temperature are almost somewhere here, which is, this is 31, right? Maybe 56. So that is between almost 100. So that will be 50. Maybe like 60 degrees Celsius, right? Approximate 60 degrees Celsius. That will convert into what? Gas. Okay. If CO2 at its triple point, I release the pressure to atmosphere 1 bar, what will happen? So let's see. Carbon dioxide gas was compressed and the pressure is released to 1 bar. Okay, so 1 bar is the atmospheric pressure. So let's go see, this is 5, maybe here, right? At 1 bar pressure, triple point. Okay, triple point, pressure is reduced to 1 bar. That means it's going somewhere here. So what will happen? That will convert into gas. So it will form gas. Okay, so that means carbon dioxide, that was this point, it was a combination, like it was the triple point. It is the existence of all the state. There will be solid, there will be liquid, there will be gas. Everything will convert it into carbon dioxide gas. Okay. Okay, next one. That is carbon dioxide. Okay. Next one is nitrogen. Okay, nitrogen. Give an acceptable pressure and temperature for solid and gaseous nitrogen to face equilibrium together. Okay, so we need to see a place where solid and gas. So remember, this is a solid area. This is a solid area. Okay, and we need liquid. Liquid is here. Okay, you can pick any value on from these lines. Okay, so you can pick any of the values from the line whereas they are in equilibrium to each other. Okay, so get one of the values. So temperature, give an acceptable pressure and temperature solid. Okay, it's asking, sorry, solid and gas. Okay, let me erase this. Okay, that's not right. It is asking solid and gas. So we need these two, solid and gas. So any value between these lines. Okay, just pick any value. So just go pick this or pick that, pick this, pick that, pick that. So any value you can say, I would say, if it is 14 psi, the temperature will be what? Minus 100 degree Fahrenheit. It's given in Fahrenheit. Okay, so 14.7 psi and negative 100 degree Fahrenheit. Or if it is 10, you can say that is if it is 10 psi, you can say it is 140. That will be negative maybe 120 degree Fahrenheit. Okay, so that is that. Then can nitrogen exist as a liquid under atmospheric pressure 14.7? Okay, let's see. Okay, nitrogen under this, so that is this region, right? It is asking this region. No. So our answer will be no, because below this region, below this pressure 14.7, only the state possibility solid or gas. So we can say no, only solid or liquids states possible below that. Possible below 14.7 psi. Okay, so the next question, the last one. Notice that solid liquid equilibrium N2CO2 lean towards the right, while on the other hand leans towards the left. Okay, that's what I said. This diagram is known. So this one is little bit towards the left. What will be the reason for that? So the reason, normally we know that when a solid convert into liquid, so solid will have higher density because they are packed together, right? Because the particles are very close together. And liquids will have a lower density. So that is true in cases of most of the substance. So that is why for N2 and CO2, the line is leaning towards the right, there is a positive slope instead of negative slope because solid carbon dioxide is more denser than liquid carbon dioxide, right? But in the case of water, we know the unique phenomena for water. Water when freezes into ice need more space. Ice will expand, right? That's why the pipe is breaking during winter reason during freezing. The reason because of the unique structure of ice molecules, because of hydrogen bonding, it will form an hexagonal structure like this. There will be a lot of vacant spaces. We learned that while we learning properties of water. Because of that, ice will have a lower density because it occupies a lot of volume, right? So lower density than water. So water will have higher density. That is why always we know that ice floats on water. Okay, so because of that, the diagram will lean towards left. Whichever one has the higher density, that is, as a solid is here, we know that. That's why the line is leaning towards the side of solid. Okay, so we covered all of the things you needed for the phase diagram. Okay, that's it.